Okay, let me just go into the details. Not a big topic that this initial part is missing. I will just repeat the most important ones. So today I want to enable you as good as possible about how to use our interfaces, but I will not touch topics such as what is routing in detail, what is a feature layer, what is time consideration in detail. You will get some demonstrations. I will process them with my test client on the live system on xServer2, which is a public resource. And yeah, okay, now let's jump into the topic right away. What is a distance matrix? First of all, a distance matrix is some kind of a storage that you can use to store KPIs such as driving time or travel time and distance values. So it's like a SQL table, which is based on a primary key plus some data columns. The primary key for such a table is the coordinates of start and stops of a relation. And the additional data we have, if we look into this, is driving times and driving distances. We also have some additional flags like whether a route was violated or not, whether a route was calculated through a direct distance or through a real routing. This is also part of what we store. This was not the case in xServer1, but in xServer2 or xDima2, this is the case. So this data is required for different use cases. I will explain potential use cases on some later slides. The primary key is the coordinates of the involved relations. So if you provide, let's say, for example, 1,000 coordinates, but only 700 of them are really distinct values, that means the size of the distance matrix is just 700 in square, for example. So these services that I use today are cloud-based. And for us, it is also important that we separate your individual data from other users' data. This is the case. Your token is what only you should be aware of. And as long as you do not share your token, nobody else has access to your values in your distance matrices. You can have several distance matrices at the time, but as I said, your data is protected through your token. Don't share it with others, and then it will work fine. So what you see in this Excel sheet, little table in the Excel sheet, is simply a very small distance matrix, two-dimensional representation of the content of a distance matrix. You see the coordinates of starts and destinations. And of course, on the diagonal, you can see that the distances from a coordinate to itself is, of course, it's just 0, the driving time. In the other cells, you can see there is a, let's say, distance of 5 kilometers, and it requires about 8 minutes to drive. So this is what we store in the distance matrix. And here with these orange cells, for example, there is also something special. Here we can see that it is a successful routing, but some violations occurred on that route. Max, if you want to add some information on that level, just let me know. Just unmute your microphone and add it. If not, I will just proceed. Okay, what you can also see here for those who have an on-premise installation of an xServer, this is a subfolder that contains the content of a Dima, which is based on a initial ini file that describes some metadata of a distance matrix, and also the data files where we have the table itself and the primary keys in a different file. That's a part of implementation that's not relevant, should not be too relevant for you as users, because in the cloud you will not have access to these kind of folders. Okay, what is not part of Dima is also quite important, because when you talk about routing, you are familiar with potential objects such as the routing polygon, the emissions based on HABIFA or different standards, list of maneuvers, list of segments, and so on. It makes sense to calculate these KPIs or these objects, but not in case of a distance matrix. When you work with the distance matrix, you don't need this data in the distance matrix. You may produce some kind of optimization output based on a distance matrix and then calculate these values for a specific route. That makes sense. So, but not in a distance matrix. So the next slides, I want to show you some different shapes and explain the correlation between the shape and the use case you can use it for. So by design, a distance matrix is rectangular. In the past, in xDima 1, a distance matrix was even square, but nowadays in xServer2, it could also be not square, but just rectangular. Let me call the distances, the dimensions, the starts, the mics, and the number of destinations is the Novembers. And in the next images, you will see a correlation between the shape and the use case. What we calculate is, even if you're asking for an M to N distance matrix, it is internally, well, created as a set of one-to-many distance matrices. Again, Max, if you want to correct me or add something, just let me know. The reason why we work with one-to-many distance matrices is because there is a specific routing algorithm that is optimized to calculate, well, and a one-to-many output based on this kind of signature of a method. We usually create a data structure where we flood a street network from a single source towards the many destinations. Sometimes it's also the opposite. Then we have a many to one shape, which is just traveling from a lot of starts to one shared destination. And this is a good example for the first two shapes. Let me just open them. I'm driven by hunger, as many of us. Here are two shapes, very simple, 1 to 4 and 4 to 1. Imagine you're located at a specific position and you have 4 different restaurants around you. Use case number 1 is you want to know which one of those restaurants can I reach in the shortest time or the shortest distance. Then it's a 1 to 4 distance matrix. 1 source or 1 start, 4 destinations. The other way around is which one of the restaurants can deliver food to my own location in the fastest way. Then it's 4 starts and 1 destination. So if you want to optimize that problem, you just have to iterate over the distances or driving times of these matrices to find out which one is the lowest value, and that's the best results you have. The next shape is a square. That is a structure you need if you want to calculate an optimal sequence for a single car. Let's say you want to visit 4 customers and you want to know what is the best sequence to visit these customers as a single individual driver, for example. That's quite easy, should be quite easy for this. You need the same structure, by the way, if you want to optimize a whole fleet. So whether you have a single car or a whole fleet where each driver has the same routing characteristics, it would require the same structure of a distance matrix. It's a bit more complicated if you have a heterogeneous fleet. Then you need a single distance matrix for each routing profile you would like to apply. And the last shape on this slide is a rectangular but non-square structure. This is an example I had from a partner just recently. He wanted to know what is the driving time and driving distances from all my own offices to all my customers. For whatever reason, in this case, it just needs a small number of starts and a large number of destinations, for example. So that was very easy to understand, I think. Now I have a bit more complicated example. Let's say you have 2 tours, on the yellow tour and the green tour, and there is a new order you want to take care of, the order number B. Of course, you want to find the best appointment, and it has to be meaningful. You have constraints, so you have to be able to perform a detour for this specific order, and you want to minimize some criteria, which is then called to be an optimal result. So that means you have to play with many, many potential combinations. And one precondition in this example is that you will not apply time-dependent routing, because this scope of a distance matrix should be based on a static model from my perspective. So maybe we could discuss one-to-one what other options you want to deal with. So here are the distance matrices I have prepared for this. 4 of them, as you can see with the colors red and black, for example. These are the relations you would need to determine so you can find the best position of B between the yellow or green stops. And what you can use this for is, let's say, yellow tour and green tour is Mr. Yellow versus Mr. Green. They are both working on a Monday. They have both existing tours. You want to know where to assign stop number B. And the other option for this kind of use case is it's just a single player, but it's his Monday tour and his Tuesday tour, for example. Could be the case. Just take your time to understand this simple idea. So these are sample use cases, samples for the shapes you may use a distance matrix for. Next thing is when you create a distance matrix with a specific method, which is called create distance, not really a surprise. So you're calling create distance matrix with a set of starts and a set of destinations. And then you also provide some options that describe how to determine the routings, such as the time consideration mode, geographic restrictions, or the usual routing parameters that we provide with our xroute as well. But I will, as I said, I will not explain them in detail. And imagine in a first call, you just want to create a distance matrix with the 3 stops, Alpha, Bravo, and Charlie. And later on the day, you want to add more stops, let's say Delta and Echo, to your planning, to your dispatching process. And then you can just update the distance matrix, and the server will enlarge the space, will enlarge the distance matrix, will determine which relations he has to compute based on the same routing options as the initial distance matrix, and then it will just add the information to the space in the yellow block here in this little diagram. Imagine extending a distance matrix could require a certain amount of time depending on the number of new relations. So nice to know that there is a distance matrix on a server, but how can it be used for optimization stories I described on the last slide? For this, let's have a look at the next slide, which compares some scenarios from an architecture point of view. Example number 1 is you want PTV to compute the relevant routing times and driving distances, but also to fulfill your optimization task. In this case, your application could use Dima to create a distance matrix or a table on the server, and then you consume a distance matrix ID and provide it as a parameter for the succeeding xtour plan tours call afterwards. So the client finally gets the optimal result based on PTV's high quality routing mechanisms. This is applying if PTV routing model is valid for you, and also if our understanding of optimization matches your functional or, let's say, business requirements. The second use case is a situation where a client cannot use the PTV optimization module because his object model is not satisfied by the PTV xtour model. For example, we have a partner who is also listening today in Hungary, a company called Nexogen, and Nexogen develops specific algorithms for optimization dedicated to specific industries. But what they don't have in their portfolio is an own distance matrix calculation or distance calculation. So for them, it's important that they produce a distance matrix on our services, consume the values of driving times and driving distances on their clients, and then apply their optimization tasks through their own engine. That's the second scenario. And the third one is, let's say, some kind of a fictitious scenario. Let's say you have you can use the PTV object model for optimization, but our understanding of routing does not match your requirements. In this case, you would need to perform routings with a third-party engine, whatever it is, upload your driving times and driving distances to PTV services, and then let PTV xtour perform the optimization. Unfortunately, this is not possible so far. This is something we are discussing currently. Maybe we will offer this approach in the future. And now, Max, I'm coming to the slides that I have just created yesterday. I want to try to keep this short. Let me start to explain what conventional routing is. This is a mechanism we use for a very long period. It's established, it works fine, and it is based on the following story. Imagine you have a street network, as on the right side, which is based on thousands or even millions of nodes and segments. So for example, a European city map is based on more than 80 millions of segments, and also requires more than 20 gigabytes of disk space, but that's, well, it is a topic you should also be aware of, even as a cloud user. Each one of these segments now has a lot of static properties, such as its length. Furthermore, it has some other properties like whether it belongs to a specific network class, highways, trunk roads, country roads, and so on. And based on the network class, you want to determine what speed should be applied on a specific segment. And therefore, once we determine the speed, we can compute the travel time on such a segment. And that's not enough. Even more properties are available. It may belong to specific categories such as toll roads, or there may be some limitation like you're not allowed to drive if your vehicle exceeds a weight of 20 tons. So all these hundreds of parameters of properties of segments influence the routing mechanism. And especially also some of these segments may be located far away from the stops, so they should not be considered if they are, especially if they are low-level classes, like in a city roads far away from the stops. Now, conventional routing means that we first determine a so-called virtual price metric, a cost value for the segments at runtime. So we compute a lot of complex operations at runtime, and then we apply our routing algorithms, for example, a standard Dijkstra algorithm, no secrets, public known algorithm, to determine what is the best path through these segments, connecting start with destination, minimizing the sum of the virtual metric. So the benefit of this approach is you can parameterize all these 200 parameters at runtime. You're very flexible, but the disadvantages of this approach is that we have to compute a lot of complex operations on the fly. The graph has to be touched many, many times to compute these metric values, and this makes it very slow. It makes it even more slower if you perform a one-to-many routing. Max, any additional comment on this slide so far?
No, it's fine.
Okay, great, thanks. And now let's compare it to another mechanism, which is called the high performance routing. Oops, where am I now? Just think I'm on the, here we go. So now let's have a look at the high performance routing. Please take your time to understand this approach, and then you will see why it is extremely powerful in some situations, but it also has limitations and disadvantages you should also be aware of. Furthermore, the following summary is only a part of the whole story. It's a rough description which is required for you to understand some of these parts. I could tell you more about them, but they are part of PTV's business secrets, and this is why I will not explain them in detail. But on a very rough level, I can let you know the following story. Imagine you know these settings of these 200 and even more parameters, and now before you compute a single route, let's replace the original 80 million segments graph and the numerous properties with a much smaller graph, which just contains the segment IDs and the metric values. Max, it's just a rough story. I hope I'm okay with that. So this is a much smaller graph. All these complex calculations of the metric values and cost values have been done in a pre-processing step only once. The pre-processing could take 10 minutes, half an hour, even 1 hour. But once the data is available, once this additional graph is available, you can use this additional graph again and again in the future, rely on it, and you can especially apply our most performant one-to-many routing based on high-performance routing. So when this approach is using the high-performance algorithms with the details I will not explain in detail, we can work much faster. It's like working with a computed index on a database. So it takes time to create the index and maintain the index on a database table for administration purposes. But once the index is up to date, you can have a very, very quick access to reading the data or to process the data based on the index. That's the big difference between conventional routing and high performance routing. So this routing in the case of high performance routing is much faster. And later on some slides, I will also show you some realistic computation times for the large distance matrices with even several thousands of stops in square. But of course, it's less flexible than the conventional routing because every time you change the routing options in your understanding of the metric, the graph is obsolete. And then you would have to re-index or recreate the search graph. That's the disadvantage of this story. One more thing that you should be aware of this high performance routing is that the preprocessed graph requires additional space on the disk and on the memory of a machine. So for a European map with about 20 gigabytes of map data, a single graph would require about 5 gigabytes per routing profile. And that means we cannot provide a lot of search graphs in the cloud on a shared system because that would produce other side effects. This is the reason why we have a discrete number of preprocessed graphs in the cloud. They are available for all of you, but you should check their settings first. First time I look into my test client, here you can see that I'm connecting to the cloud. Here in the settings, this is the test system I'm using right now. By the way, also the experimental API. And now I can ask, for example, the cloud with a specific method of xdata. The method is list high performance routing networks. I just ask the server itself, give me a list of the search graphs you can provide. I get a list of 4 search graphs. Each one of them has a specific ID, unique ID, and also a label. And if you want to get more details about a specific search graph, you can look into the profile that is also returned by that method that describes the routing options that have been used to produce the search graph in the pre-processing step. Another aspect of the pre-processing is that it does not make sense to combine it with dynamic time consideration modes because the status of the segments and therefore the metric depends on other factors in dynamic routing and they are not known during pre-processing. For example, in the pre-processing phase, there is no station, there is no waypoint at all. We just compute the prices for lots of segments. And afterwards, in the execution phase, then we deal with waypoints, but not in the pre-processing. A specific time consideration mode like exact at start, for example, depends on waypoints. So this is why we cannot consider this in the pre-processing. We cannot create a search graph, or it does not make sense to produce a search graph which is based on time consideration mode exact at start. Is that correct, Max, or anything to add on top of this?
No, that's perfectly right. So
great.
Nothing to add.
Okay, great, thanks. And finally, you should be aware that you cannot overwrite properties of a search graph. So if you have created it with a specific profile and you want to perform routings based on a routing profile where just one single parameter is different, this is not going to work. You cannot combine a search graph with changed or with routing options on the fly. If you try this, you will get an exception in the response. Okay, so much about this difference between high performance and conventional at the moment. Okay, so this is just a rough summary of the things I described in the recent seconds. The concept of tour optimization with xtour is based on a built-in distance matrix, and that means the xtour itself created and maintained the distance matrices by himself. The major parameters in the old API have been the ID of a Dima, a routing profile, and whether the distance matrix should have been deleted before or after the usage of the distance matrix. And furthermore, the creation of the search graph was done by an additional command line tool. In xServer2, the tasks have been splitted. Creating a search graph, that's an on-premise topic more or less. Creating a search graph is done by methods of xData module. And then the creation of the distance matrix is part of xDima module. And finally, you can use xData and xRuntime to get some more information about the server and his state or the data it provides that you can use, profiles or search graph names. And finally, we have some parameters that you can use to reduce the scope of distance matrices. Sorry, just a second. And in the end, the user is responsible, the tour optimization user is now responsible to make sure that he provides the distance matrix by a call, which is done before the tour optimization call itself. So much about this. So next slide, I want to show you some scenarios where you can use a distance matrix, and I want to draw your attention to how to maintain it. Let's say we have two use case scenarios out of many potential scenarios. They both have one thing in common. They both deal with last mile optimization, but the difference is the kind of the involved stop. Let's say the business-to-business scenario, a parcel delivery driver deals with the same stops every day. A few times per year, he gets some new stops on his everyday route. Sometimes stops are moved to another driver or deleted from the scope at all. In this case, it is meaningful to create and keep his individual distance matrix, and if needed, extend it every once in a while. To update his distance matrix, this can be done with flexible routing options with conventional, with the best quality of the routing KPIs. That does not mean that high performance routing is not precise, but there's another reason for this. You just have access to all the parameters in the conventional routing on the fly. In the business to customer use case, a driver would have to visit different stops every day, and therefore keeping his distance matrix would create a lot of relations or waste a lot of space that would never be used. So therefore, I recommend to destroy and recreate his distance matrix. And in this case, you probably may have to use high performance routing to be fast enough in the computation. So that slide has just made its way into this without being necessary. So here it goes. Here is the next slide with an overview of the methods that are provided by the xDima method, by the xDima module. Let's start with create distance matrix request and create and get distance matrix request. These two methods trigger the calculation of routing KPIs on the service. The difference between them is that in the first case, you produce content on the service, and this content will be stored over there and it will be kept over there. The second method, create and get distance matrix request, has almost the same signature as the first one. The difference is that with this method, you can already consume the results on client side, but it's also important to know they will be destroyed right after the request. Max, anything to add on this level?
Maybe only that there is a limitation for the create and get distance matrix request in terms of size, but apart from that, no.
I'm not aware of the maximum numbers. Is that in the past there was something like not more than 700 in square, or so that's probably because of the response size, right?
Yeah, I think it's 250,000 relations at the moment.
Okay, which is a medium level if you want to consume them all at the same time. Okay, the next method is the extend distance matrix request, which is of course what I displayed with the yellow bars after in the second call. You just add additional relations to a distance matrix once you have created it with create distance matrix request. So these are the methods that produce content. They trigger routing. The next method is the one that you've already seen, list distance matrices. Let's just ask the server for what are the distance matrices I have already created in the past. When you use your token, you have access to those distance matrices that you have created. You will not be able to touch other users' distance matrices, and they will not be able to touch your distance matrices. With list distance matrices in the client, I can just get a list of the distance matrices I have created by myself. Let me just trigger this. Could take some time. What you see, or what will be part of the output, is probably almost the same thing that we've just seen in the grid. So this method gives you some KPIs of the distance matrices that are already in the system. For example, what is the number of starts and destinations? So these are quite small distance matrices. This is a much bigger distance matrix. It also lets you know what is the type of routing that has been applied for this distance matrix. Was it a high performance routing or was it conventional? Of course, a distance matrix of this size needs to be done with high performance routing. It would not be, well, I would not want to wait so long for a distance matrix of this size on conventional routing. You can have additional parameters like what are the countries that you are allowed to use. By the way, they are in this case part of the 4 standard search graphs we provide in the cloud. And if needed, you can also provide a blacklist of countries where you're not allowed to drive. In my example, I have created distance matrices with different time consideration modes. It is possible. I did not say it's not working. I just said it doesn't make sense to combine this with high performance routing. So for tour optimization, for example, you could use a distance matrix with an optimistic time consideration or even with multiple travel time consideration if the context of the tour optimization is matching your requirements. There is also some additional properties like when has this distance matrix been used the last time. This is important because every once in a while we do some kind of garbage cleaning and we remove distance matrices that expire. It's quite important to know. So don't expect the distance matrix is there even after 3 months. Make sure you have a business logic that ensures that the relations or distances you need are updated at the moment you want to perform an optimization call. And of course, if there is a list something method, there is also a delete something method. I have implemented an example where I can just select several of the rows in my grid, perform a multi-delete, and then the distance matrices will be gone. Here we go. If I perform list this in update, I will get this table now with a few less rows. And what I can also get back from the interface, if I ask for a specific distance matrix like that one, which is a small one, I can also get the coordinates of the starts and stops. In this case, they are equal. Both arrays are equal. And I also implemented a little visualization so we can see if the number of relations in the distance matrix is quite small, then I can also display it on a map like this. Okay, but that's fancy stuff. That's additional things. As I said, there's also delete distance matrix. Next thing is get distance matrix. This is needed if you want to consume the content of a distance matrix on a client. Remember, create distance matrix will produce something on the service and return a string, an ID, just a complex ID that you can then provide to the xtour module to refer to the distance matrix. But you would not consume the driving times and driving distances on client side with this method. You consume only the ID, and then you can forward the ID to the xtour. If you want to perform an optimization on client side, you need to gather the relations and the KPIs on client side. This is why you need get distance matrix for. Here we go. Once again, let me look into my test client and ask for the distance matrix. So if I ask for get distance matrix, oh, that's slow. Let me just create a new distance matrix. This interface will just read 11 lines from a file I'm now selecting. I will apply high performance routing with a search graph ID that I have retrieved from here. 11 in square. It's a square matrix with that button in this case, and anything else I need to apply now, I think it should work now. So what is also important is I use the asynchronous protocol. With a small distance matrix like this, the result is consumed very fast. Let me just add some more stops. Let's say 111. So I will start the calculation of distance matrix with a call that is start distance matrix. I calculate distance matrix, use the asynchronous protocol, which means I consume the ID of a calculation job, which is this one. I ask for the status of this job every few seconds or parts of a second. And once the job is in a status that we call succeeded, I have access to the result. So if I look into the distance matrices now, well, not this one. Then you should be able to see the new distance matrices I have just created. You have seen it was very fast. Well, it was very small distances, distance matrices as well. And here we can see the label distance matrix 111 in square, and that's what I just computed on the service. Now let me get that distance matrix. You can consume the result of a distance matrix in two versions. One version is in plain values. That's what I did right now. But it's to be more performant, you can ask for encoded arrays. So I can get the same logical information by just changing a parameter, get distance matrix, and then I get a compact version of the content of the distance matrix. Probably not that big relevant feature for you because most of you will use the distance matrix with xtour on the server. So let's just go back to this. What we can also see is that some of these relations have zero distances, which is in a square distance matrix. You will see them quite often. Some of these relations have been violated. That means one of these coordinates is probably in an area where it's not possible to reach it without any problems, but we did manage to by applying violations. That's it. And in this case, you can also see that all these, oh, come on, I wait for the tooltip. Should be a tooltip. All of these relations have been calculated by the routing engine. None of them is false. False means we would have replaced the driving time and driving distance by airline-based approximation. There's a difference, once again, to xServer2. In xServer2, if a routing was not successful, we just stored an error value in the distance matrix, and a stop that was not reached successful by the engine, we would not schedule this stop in an optimization. In this case, as every time you produce or you ask for driving times and driving distances has a value, we will be able to schedule all these stops. So as I said, get distance matrix is the method you need to ask for a distance matrix values on client side. Now let's just compare them to SQL services, to SQL statements. The first statements, the create values are like insert statements. The second one is like an insert statement, and afterwards it's a select statement, and then it's a delete. The third statement is Just a SQL insert without an update, because you cannot overwrite existing KPIs in the distance matrix, you can only extend it. The next statement is like a SQL, well, whatever. It's like asking SQL meta tables about their content. Then we've got a SQL select statement for requesting, sorry, a SQL drop statement for getting rid of existing distance matrix, not only removing the rows, but even dropping the whole table. And finally, the get distance matrix is a SQL select. Maybe this helps you to understand some of the concepts. Okay, guys, any kind of questions I did not cover so far where I could maybe give some demo or instant feedback on audio? Is that something you would like to forward to me? If not, I will just proceed. You have 10 more minutes, and I have some more slides to present. On the next slides, I have collected some statements that you should be aware of. It would be helpful for you, quite sure, if you have these statements in mind. What statements like what you can combine with each other, what you cannot combine, and so on. Keep in mind, the structure doesn't have to be square. It could also be just rectangular. Keep in mind that all relations within a distance matrix have to be based or will be based on the same routing profile. If you want to change the routing profile, you have to delete and recreate the distance matrix. It is not possible to change the profile of a distance matrix, so you have to recreate it. It is not possible to delete single rows or columns of a distance matrix. And at the moment, it is not possible to upload your own relation KPIs into a distance matrix. Be aware of the difference between high performance routing and conventional routing. Just some side note, a single relation requires 8 bytes of space on the disk, and it could be even more than 8 bytes if you ask for more data, for example, toll or multiple travel times. If you work with multiple travel times distance matrices, keep in mind that all the single relations, single routes will be based on the same routing geometry. We just apply different time settings, dynamic time settings on the track, on the geometry of this individual track. So another info, the standard cloud does provide access to search graphs. We have the custom cloud if needed. We have some customers who cannot work with the standard search graphs, who need their own individual search graphs, which you cannot compute by yourself on the cloud, on the standard cloud. And for this, you would need a custom cloud if you need both the parameter setting of specific routing in combination with the performance of high performance routing. For this, you can only work with a custom cloud or on premise. Custom cloud means it's a system we would especially create especially for you, but there's also different pricing behind that. Today, we have 4 different standard graphs in the cloud. You can ask for the IDs through the method I've already shown through xData. Be aware that the ID of a search graph on the test environment is not the same ID as you would have on the production, even if the routing profile or the search graph's logical content is the same. So be aware of this. So therefore, do not hard code the IDs of the search graphs. Create a logic where you are not depending on hard coded IDs, because furthermore, these IDs can also change after a map update. And one thing I would like to demonstrate again, maybe some kind of a challenge for the development team. If you look into these parameters for the list distance matrices call, I have enabled the method call to provide every information that is available from the list distance matrices call. I have small matrices, I have larger distance matrices. What you see right now, it takes quite a long time to get the grid filled with the information of the distance matrices I have created in the past. So that was about 15 seconds. That's really a very long time for just a simple, give me some metadata about that about that. If you do not ask for everything in detail, these are all optional response elements. I probably do not have to wait 15 seconds. I hope so. Yeah, just 6 seconds, still enough time, but I can just ask for what are the distance matrices I have and maybe implement a logic that simply touches distance matrices that have expired somehow. Okay, so maybe you have to touch your distance matrices every once in a while if you want to recycle them. But as I said, be aware of that we could delete them if needed every once in a while. So when should you read or write a distance matrix depending on your use case? So one use case or one trigger is if you have new locations in your horizon, you need to extend your distance matrix. So whenever your master data is updated, your depots, new offices, new customers, then you would have to insert data into the distance matrix, extend the distance matrix. Next scenario is when PTV performs a map update on the cloud, for example, then you would have to recreate a distance matrix. I know this is not very nice, but it's required. At least once per year, we update the cloud map, and better data means better routing info there. So it's not only a task for you, it's even improving your data that you could use afterwards. Next thing is whenever you want to update your profile, imagine your central corporate, your organization decides to change some kind of parameters like the speed on highways or the prior of distance versus the period, then you may have to recreate your distance matrix. For this, I recommend, as I said, to use the asynchronous protocol. There's a little kind of diagram on the side. Okay, what kind of errors could you face? Let's say you could face errors if you if a partial routing was not successful. In xServer1, this produces an error. In xServer2, this just returns a successful KPIs. You can use that relations, but you will get a signal flag on the distance matrix that tells you this is an estimated driving time and driving distance, for example. So relations which are in the system but not routed successful will be replaced by airline. And finally, on this stage, what is quite important for you, the creation of a distance matrix. Let me just compute my small distance matrix, 111 in square. Let me reduce it to, let's say, 50. Use conventional routing once again. So this is now producing a simple 2,500 relations distance matrix. And in the calculation, you should see that it takes much more time to proceed it. And that's just a very small conventional distance matrix. Once again, asynchronous protocol, many different status calls. And finally, when I have reached 100%, I will be done. The thing is, if you create a distance matrix, right now in this scenario, it will take about 40 seconds to produce the 2,500 relations matrix. If you want to create a bigger distance matrix where it could require several minutes to produce the distance matrix on the server, you will not be able to work without the asynchronous protocol, because if you start a transaction or if you create a distance matrix with a single create distance matrix request synchron, it will produce and open an HTTP connect to the cloud, and this connection will be interrupted by Azure after 3 or 4 minutes. That's not a PTV topic. That's really an environment topic and a setting from Microsoft that HTTP connections will be disconnected after 3 or 4 minutes. And this is why you should work with the asynchronous protocol, because this just creates a start of something, a task that happens, and then every few seconds, I will just perform the watch call, which is handled immediately or responded immediately. And finally, once I get a new status, which is successful or failed, I will just consume the result. That's quite important. That's only working in Azure with the asynchronous protocol if you are working with larger distance matrices who require more than 3 minutes for the computation time. So some statements about performance. So I was asked recently whether the application of feature layers has an impact on performance. Yes, it has. So be aware, applying feature layers in a routing context, whether it's one-to-one routing or one-to-many routing, has an impact on the routing performance. So therefore, you could consider to apply the optional parameters for geographic restrictions. For example, in the routing call, you could specify, let me go back to the distance matrix, Dima, allowed country, Germany, create my distance matrix again. Once again, 40 seconds. But now I have told the engine that the truck or the driver is not allowed to leave the country. This is a specific restriction. It has an impact on performance. It will not take 40 seconds, now maybe just 30 seconds or 20 seconds. Check this if this is okay for you. The impact, 25 seconds compared to the other ones. Let me have a look at the list distance matrices again. Well, that's not just ask for them. The impact is not as significant as the difference between high performance routing and conventional routing, but it should be you should be at least aware of this. And here you can see this distance matrix. They both have the same size. Oh, didn't ask for the size. They both have the same size, but one of these distance matrices is based on the routing is not leaving the country of Germany, for example. Here we go, same size as promised. So next thing is, if possible, if you are working in a session as a dispatcher, try to use a session-based distance matrix. Create it maybe at the beginning of your dispatching session in the morning, for example. Do not recreate it every time you want to change the scenario in your plan tours request or change tours request with xtour module. And try to use high performance routing instead of conventional routing if possible. So next slide is very short information about a new feature we have implemented in our version 2.19. That's a parameter that is called off-road route location, or that is available for off-road route locations, specific kind of waypoints. That's a parameter which is called consider driving side. On the left side, that's the default behavior that was implemented at the beginning of our xServer2. In the map, you can see that's the use case of garbage collection. I have some garbage containers located in one single street, and by using the regular approach of the distance matrix with off-road route locations without considering the driving side of the truck, the driver would have to change the road, the sides of the road, almost with every garbage container. And this is not what you want usually. With this new parameter, which we've invented in 2.19, you can specify that the truck has to stop on the side of the coordinate, of the off-road coordinate. And that's why even the routing or the optimization result now looks different. That's the same, let's say, sorry, the same orders in both cases, but on the right side, I have parameterized the distance matrix to consider the driving direction of the truck. So the content of the distance matrix is now different, even if the size of the Dima is the same, but the content is different, the KPIs, driving times. And this is why the optimal sequence has a different structure. That's what you would like to have in the context of garbage collection, for example. Okay, so much about this. Then I have collected some examples for distance matrix calculations. You've already seen them with the test graph. You've seen that we can ask the service for what search graphs are available. You can ask for what are the distance matrices that are available. I have already created a large distance matrix. By the way, let me now compute a very large distance matrix. Let me just remove this once again. Ask for this search graph. remove this allowed let me just try to use it and run into an error by design. PLZ5. And this should now produce a distance map. Well, first of all, this should produce an error asking for a search graph in combination with an explicit option like the whitelist of the countries produces this kind of error message. So let me just, that was by design. I wanted to show you this effect. Now let me remove that parameter and then ask for the distance matrix again. Now I'm calculating a distance matrix with the asynchronous protocol using a high performance search graph with 13,000 coordinates in square. So that's quite a long distance matrix, quite a big distance matrix. It will take about 1 or 2 minutes, and that gives me the option to ask again, are there any questions in the chat I should take a look at? Colleagues, already running into overtime. No questions so far? Then let me have a look at the slides. In the meantime, I can show you some. Oh, now it starts the job for whatever reason. In the meantime, I will go back to the slides. This is some calculation times you can expect on a system with the following characteristics. So very high performance based, very small distance matrices in just a few seconds. Larger distance matrices with 10,000s in square, about 1 minute. The largest distance matrix I have ever calculated on this Dell notebook was a 40,000 in square and took me about 16 minutes to compute it. And it produced 9 gigabyte or even almost 10 gigabyte of data in the distance matrix folder. So what you see is how it is connecting the number of locations in a distance matrix with the computation time. Okay, there's some more information about general approaches, like considering the different aspects of conventional or high performance routing, taking care of whether you want to override a distance matrix or not. I will not go into detail there. I prefer to have a look at the following slide. That's more important. One customer said, I have produced a very big distance matrix on the service, and then I wanted to consume the content on client side. And as Max mentioned, the number of or the size of the responses for get distance matrix calls is limited. So this is why you can simply cut your 100% distance matrix into small chunks and then ask for these rectangular substructures. That's also possible. And of course, you should consider to work with the encoded arrays instead of the plain distance matrix KPIs itself. Now let me have a look into the status. We are about okay, go back to the slides. Here's just a little overview of the pros and cons of the standard cloud, the custom cloud, and an on-premise installation. I recommend when you start nowadays, I recommend to have a look at the standard cloud on the left side. It's cheap, it's performant. You do not have to administrate the system. On the other hand, you should be aware of that you have some kind of limited flexibility. If you want to work with custom search graphs, this is no path for you. But first thing to check is whether the standard cloud is working with you. The next slides, I will just show you that they are available. I will provide the PowerPoints anyway. Is, for example, somebody asked in the German version of the webinar whether the results of high performance routing and conventional routing are comparable. I have described some lines over there, so you will get these slides afterwards. You will get these answers as well. And in the same way, I will take your questions from the chat, have a look at them, try to write some answers, add them to the slides, and then provide it to you afterwards. That was what I wanted to show you today. Thank you very much for watching. Once again, the question to the chat moderators, is there anything else I should draw attention to, or do you have questions I could, or maybe demonstration? By the way, result is now there. Here we go. Took me about 3.5 minutes to compute this distance matrix. And if we look into the list distance matrices, maybe not ask, well, let me ask for them, for these KPIs as well. Then you will see that I have created a distance matrix with the same size as here. I have practiced this in the past, of course. If you have further questions about the topic of distance matrices, I am aware that you might have to discuss your use case in detail with me, one-to-one, or with one of the consultants in the offices somewhere else. Just get back to us. The meaning of a generic webinar is, of course, to give you as much information at the same time and then to handle you each on an individual way. You can find additional information on the xServer forum. And the next webinar I will provide is tomorrow in German. That's just a new format I want to try. It's an open discussion. Customers ask me for topics, they recommend the topics, and tomorrow we will discuss these topics in German language. If you are interested in this, have a look at the forum once again. Let me just show you where you find that information. Here's the xServer InfoStream forum, the post about webinars 2020, and here you can see the open discussion tomorrow. I might add future webinars here in this list, so what I recommend is gather a login, register yourself, subscribe to this topic, to this webinars thread, and then you will get notifications automatically about that I'm providing new webinar sessions in the future. That's it. So far. Oops. And that's what I wanted to show. I hope you have seen and gathered a lot of information. Thank you very much for joining and see you soon. And also a big thank you to the team for assisting in the chat. Was a great pleasure for me today, and I took only 10 minutes over time. Here we go. Okay, thank you and bye-bye.